very good afternoon to everyone. I think we have an August panel here today to also discuss a very interesting topic here about how do we prioritize the short term versus the long term in terms of emission technologies, in terms of pathways to decarbonization. I think we as a country and as an industry, the automotive industry, see that there are several pathways to sustainability of transportation, whether it's electric vehicles, whether it's hydrogen in the form of fuel cell electric vehicles, natural gas, or even improvements in the internal combustion engine. But at the same time, there is also the talk of how do you balance out the priorities as OEMs, as suppliers, as test agencies between managing what is needed immediately, for example, meeting CAFE, meeting RDE, or strengthening the alternate fuel adoption in the long run. Also, for managing this transition in the long run, I think there are some imperatives that need to be looked at, for example, securing enough raw materials, looking at localization of manufacturing, talks about having enough electricity and a stable grid, some of the things that were also being mentioned in the previous session before this, as well as customizing products for India. I think in all of this, there is also a role that the government and the policymakers play, and what interventions could be sought from them to ensure we manage the present while also gearing up for the future. And finally, does also a long-term regulatory roadmap help in keeping everybody ready for what is going to come and be able to pace up the developments in the industry accordingly. So I think to touch upon all of these topics, we have an august set of speakers with us who would be taking us through how we can, as a country and as an industry, prioritize some of these things. To kickstart the panel discussion, maybe I would start with you, Mr. Saurabh Saxena. And the question to you is, India is ready to see this immense growth of EVs in several vehicle segments in the coming decade. Simultaneously, we also see there's a push on regulations like RDE, CAFE on IC engines, and that's going to also increase the cost of development and hence maybe also the prices. In addition, there are high duties on fuel. There are also higher taxation on internal combustion engine vehicles, which might also in some way or the other also sort of mute the demand from an end consumer perspective. Therefore, how does an OEM kind of prioritize between these two things? Because you need to keep selling what you're selling today in order to also fund the transition towards a cleaner mobility in the future. So what sort of prioritization or, what sort of maybe alliance work development or things can be done so as to be able to balance between these two conflicting priorities?
Thank you for your question. Asim, am I audible?
Yes, very much.
Fine, thank you. So, I would first like to give some background why we are in this situation. See, we as transport industry or automotive industry are contributing to around 15% of the CO2 emissions out of India. Yeah. So that means the big responsibility lies on our shoulders as well to contribute, make our nation carbon neutral by 2070, which is, by the way, our commitment to United Nations, right, in the climate conference. So we all have to work towards this. There is no doubt or there is no ambiguity on that, because IC engines since several decades have been contributing into this pollution, be it environmental pollution, noise pollution. So we were partly responsible for this situation. And now we also have to contribute in giving solutions so that we can make this environment and this society livable. We need to pass on a clean and livable environment for the next generations. So in order to do that, IC engines alone is not sufficient. We need to look for greener solutions, be it battery electric vehicles or hydrogen fuel cells, to reduce the carbon footprint globally. So as you rightly said, these technologies are costly. It will have an impact on the consumer. It will put an additional demand on the infrastructure side, from government side, on the whole society. So a shift in the behavior is needed from the automotive companies, from consumers, and also from the policymakers, right? So I think given the size of this big subcontinent and the consumer behavior, there cannot be one solution to this situation. I think the IC engines will coexist along with the greener technologies like battery electric vehicles or hydrogen cells. But this is a time where we can use IC engines for switching to greener fuels like methanols, ethanols, biofuels, CNG, LNG. So with these technologies, we can still make our IC engines work more efficient and lesser impact to the environment while we slowly and steadily, progress towards cleaner technologies. Yeah. So this is how I see that for some point of time, both these technologies will coexist, and eventually we will make our progression towards the clean solutions or sustainable solutions, which are environment friendly.
All right. Thank you very much for sharing that perspective on how, in a stepwise manner, while the technologies are coexisting, slowly we will dovetail towards the greener ones, right? I think with that sort of context in place, I would like to take the question over to Ms. Pamela Tikku, because I think from a testing agency perspective, the workload is even more. We have a whole host of powertrains out here, and all of those are going to see upgrades in terms of emissions, apart from all the safety upgrades also that vehicles are seeing. So from being ready from a testing infrastructure perspective, right, immediately you need to do something to get, say, RDE in place or CAFE in place. But at the same time, you also need to gear up for somebody who wants to test an EV or a fuel cell vehicle, wherein the volume may be very less, and hence the utilization of some of that infrastructure that you set up will be very low. But if you don't have that infrastructure, we can't have testing of that vehicle locally. We can't have development of that vehicle locally. So essentially, the infrastructure becomes a must-have in this case. So how are you trying to balance out between these priorities, given the whole host of powertrains that we as a nation and as an industry are focusing on?
Thank you, Ashim. I would first like to extend my gratitude to Dipanshu and Vivek for inviting me for this very interesting session, Powertrain of the Future. So future is dynamic, and hence the powertrains are also dynamic. So every 2 years, the roadmaps keep changing. Your pertinent question towards the challenges that we as test agency face with this dynamism is equally challenging as it is for any OEM or a technology partner. Unless and until we as test agencies don't have infrastructure to test, certify these products or the technologies or the standards which are notified, none of these technologies can see the day of light in India. So we as a technology enabling entity have to be aware of the ecosystem and the environment that is developing. And that happens primarily because of the kind of deliberations from the regulatory point of view happen, and any regulations which gets notified takes 2 to 3 years time to implement. And that gives us some time to plan and upgrade ourselves to embrace the vision of the government. And such facilities are not cheap. They are very expensive facilities. And the procurement time is also very long. So it takes at least 1.5 years if we decide today to build up a facility. Sometimes more than 2 years, because in case we need to create a building and utilities and all, so it takes 3 years time frame to set up a facility from a greenfield point of view. We are ready in terms of availability of infrastructure, whether it is for EV adoption in the country or it is for biofuels or gaseous fuels. So we keep upgrading constantly, keeping in view the regulatory requirement, also the development requirement, because many of the OEMs do not have R&D centers in the country. And agencies like ICAT provide that infrastructure for people to develop those technologies. So firstly, it is to develop. Once the OEM is satisfied that the technology developed meets the regulatory or standards that are there, then they go for certification. So we have to constantly evolve our infrastructure, constantly upgrade our infrastructure, and also skill sets. While you may be able to procure test facilities globally, but to develop the skill sets of people to handle those equipment, to interpret the data, to analyze the data takes time. So we have to be constantly do both, enabling development of skill sets as well as infrastructure. So ICAT currently can cater to all kind of powertrain requirements, whether it is gaseous CNG, LPG, LNG for that matter, which is the upcoming fuel option for heavy duty application, electrified vehicles, be it fully electric or hybrid vehicles. And also, it's not only a vehicle level testing that I'm talking about. So there are a lot of component level testings also which happen. For example, in electric vehicle, there is an intensive battery testing which needs to be done. There is an e-motor testing which needs to be done. And we have upgraded the facilities to cater to this wide range of requirements. In terms of biofuels, biofuels is also evolving at the moment. So whether India is going to have a flex fuel or it is going to have 20% ethanol or 15% ethanol, that deliberation is still going on. The roadmap is under finalization. So we need to cater and develop our infrastructure for flex fuel application, which is under process. In terms of LNG certification, we can do for RD, you mentioned, we created RD capability in ICAT way back in 2015-16 when we were involved in data collection for developing Indian RD program. And we are able to do RD testing for passenger car vehicle as well as for heavy duty applications. Gases fuel we have been doing for a long time. So CNG, LNG is the new fuel which we are already testing.
All right. Right. Thank you very much for, sharing that, and also that you were ready for all the fuels. And also, I think very important point that you touched upon was it's not just the physical infra, which has its lead time, which has its investments, but also the skill set which needs to be developed. So, at the test agency level, again, you need people who are skilled to be able to test out so many different vehicles, interpret the test results and things like that. So thanks for sharing that perspective. Moving on to Mr. Sanjeev Saxena, and taking it from a component manufacturer standpoint. So we see that there is a focus on multiple powertrains in India. So we have EVs, we have natural gas, we have hydrogen, we have improvements in ICE, hybrids, etc., so on and so forth. And you as a component maker then need to cater to all of this. Do you see that from a government standpoint, probably there is more focus on certain things and less on certain others, and probably a bit of a reprioritization may be needed in order to also ensure that as a component sector also, we are able to localize most of the parts that are going to go into these different powertrains, especially the upcoming ones?
Yeah. First of all, thanks for having me here. And before I come to this particular question which you're asking, let me just give a little bit more thoughts how we think at Schaeffler about the future. So we're clear that it is not one size fit all. So every segment will have a different kind of penetration. Every segment will have different kind of powertrain scenario. 2 3-wheelers, it's a different ball game. When we come to the fast car segment, the LBS, we call it, up to 6 tons, it's a very different ball game. And when we go above MHCV, that kind of vehicle, then it's a very, very different ball game. So we have actually, and so that's on the segments. And then it is on the time frame. We have to slice the future into time frames. Of course, we can only predict so much. We can do certain crystal ball grazing and come up with the several scenarios. So we have actually developed the scenarios globally as well as for our country here in India. And we look at what kind of powertrains will be there by 2030, what we can expect by 2035, and going beyond that to 2040 and so on and so forth. So that's very kind of very long time. And one thing that we see clearly is that the technologies are going to coexist. India probably will be the last country which will see ICE engines, I mean, it'll be the sunset technology, it'll set in India. That sun will probably set in India. So it is going to continue. What is more important to see is that when we look at the projections, now I'm talking purely LV side, like vehicle side, we are anyway going to double the vehicular production in next maybe 10 years or so. And that's what the projections say. And even if we take the best case scenario of 30% electrification and certain hybridization and the other ICE, we still see that ICE are going to grow pretty big time. So while you keep on investing for the future technology, it is very important for us to make sure that we bring in the best technologies which are available into the current powertrain system. So that's basically, it's a three-pronged strategy that component makers like us and the technology solution provider like us have to work on. We have to make sure that we keep on serving our customers with making their vehicles leaner, more carbon efficient, more CO2 efficient, by way of reducing friction, of course, and by way of making sure that the energy losses between the engine and the wheels are minimized to as much as possible. So we have technologies in that area. The second area comes like I was hearing the previous conversation, also hybridization. And it's anybody's guess what's going to happen here in India, but we believe that there will be certain hybridization percentage, and hybridization is a powertrain which is definitely going to play a role here in India. Accordingly, we are looking at those technologies. What are those technologies? We are partnering with the global customers, making sure that we are partnering with them in other countries, bringing those here. The local customers might think otherwise, but there are global customers who are clear that these these technologies will have to coexist. One more thing from the market point of view. Unless we have all three, the ICE, then the hybrid and EV available to the consumer, then probably you miss out certain part, because consumer is becoming more and more discerning. We might sit here predict consumer behavior, but we know that the consumer 5 years down the road is the youngsters. That's Gen X. That is, and they really make their decisions based upon what they know at that point in time. And that is something which we need to be all aware of. So during that time, if you have options, I think that will be a very good idea. That will make very good businesses. Also, when we look at the new entrants, the certain vehicle manufacturer which is coming from our neighboring countries, we also see that they are bringing in everything. They're not just banking on one kind of technology. So that's basically will define the future. Now, coming to what we are doing about it, what is our thinking? So based upon our various powertrain scenarios, we are making the localization plans, so to say. We all know about VLI scheme and so on and so forth, to bring in technologies into each and every segment. And the objective here is to ensure that we not only work directly in the production of a machine, but indirectly also. That the indirect ways are offering much lesser friction and weight reduction. I think these two are very major areas where all the components that we manufacture, we are looking for solutions in those areas. And when we look at, once again, when we look at maybe 2040 and beyond, yes, there will be different technologies when the SKU would have changed. One very important area that we need not forget, especially in the commercial vehicle areas, is and also in the stationary areas, is the hydrogen fuel cells. I think that is something which we have to all watch for. That can be a surprise, which when the smartphone, what smartphone did to the Blackberries and so on and so forth. So that could be a surprise package which may catch all of us napping. So that is a scenario we need to be aware of. And at Schaeffler, we are evaluating those scenarios very, very clearly and making sure that we are investing into each and every. No, may not be here in India, but globally we have those solutions available, and we at the right time we will be able to bring to the country here.
Got it.
Thank you.
All right. Thank you, Mr. Saxena, for sharing the 3 strategies that you're working at, making vehicles leaner, hybridization, also EV, and how indirect and weight reduction. And later in the conversation, I'll also come back to you with some specific EV bearing related questions also. And of course, for pointing out that FCEV surprise, which yes, all of us need to always be ready for. Moving across to you, Mr. Saravanan. So, you've had a very rich experience prior to your current role, also in an OEM role with Mahindra. So, could you shed some light on, how a new regulation is being approached by an OEM? Before it translates to an optimized powertrain for reduced emissions. There are, of course, the roadblocks of higher cost, and then you need to take certain measures to avoid these roadblocks, both as an OEM and as a supplier, the government and the testing agencies as well. But we see that it's more happening linearly, like all OEMs are gearing for the next step in their various regulations. Do you also see a possibility that people say, okay, no, we're going to just leapfrog to another technology in order to meet, say, CAFE or things like that happening in the future? So your perspective on that.
Thank you, Ashim, and thanks to Mobility Outlook for this opportunity, and good afternoon to everyone, the panelists and the listeners as well. One thing that as an OEM, just to give you, I was with multiple OEMs earlier, and now I'm with a component manufacturer. So just to give a rough idea, typically a transmission development takes around 100 crores, and engine development, let's say 400 crores or something like that. And your vehicle development is around 1,000 crores if you're going to do a brand new. So at this point of time, this investment, when somebody tries, let's say I'm an OEM and I'm trying to invest in any new engine or a transmission, I need to look at the recovery of the money that I'm investing. And at this point of time, irrespective of what many OEMs say, none of them is actually very keen on investing in any brand new engine or any new transmission. They're only doing modifications to what already exists because nobody's really sure. We heard Dr. N. Saravanan from Ashok Leyland earlier, and Mr. Madhavan as well, and the other speakers from Maruti, for example, like Ajay. So nobody is very clear as to what future holds. So at this point of time, putting big time money in a new engine or a new transmission is something you would not want to do. And so what you do, you try to stretch what you already have. And that's what most OEMs are doing. They're trying to see, okay, if I have an engine that's in diesel, can I convert it into a natural gas, or can I make it like a flex fuel? So these are the kind of things that people do. The second thing that an OEM, typically does is predict the future. Right? They try to predict the future. So you try to talk to various consultants, various, let us say, people who are able to predict. Now, one thing that is coming out, if you look at the world scenario at this point of time, if you look at from an emission standpoint, the world is already at somewhere close to Euro 6 and Euro 7, the way it is being discussed, like they will look at a particular matter of 10 nanometers or below, then aldehyde emissions, ammonia emissions. The way it is going, it will be practically close to zero. Even if it's not zero, it will be practically close to zero. And nobody would even possibly imagine what Euro 8 would even look like, because we are already touching the bare bottom. Right? At this point of time, it may be even if there is a Euro 8, for example, and if you still plan to use something like an IC engine, it's not going to work because we may be putting so much CO2 out in terms of manufacturing of the exhaust control components. So it's going to be not a good outcome as such. Right? So if we look at from an emission standpoint, we are already bottoming up and very close to zero. Now, if we look at from a CO2 standpoint, right? CO2 standpoint worldwide, if you look at even US, US was a laggard for the last 10 years, but now again, they are picked up. So they are looking at something like a 1.5% per year reduction in CO2. Most countries, including China, are looking at somewhere from 3 to 4% CO2 reduction, let's say from 2020 to 2025. So 1.5% to 3.5%, let's say 3 to 4% reduction in fuel consumption or CO2 emissions doesn't come easy. Typically, if an engineer is going to tell an OEM, I'll give you 5% reduction in CO2, the OEM will put that engineer on his shoulders and move around. He'll be so happy. So these kind of reductions at a sustained level, I mean, maybe for 1 year it's possible, 2 years it's possible, but at a sustained level, they don't come easy. So if you look at, and the third thing is the way different countries are also telling. Like, for example, Norway has already said by 2025, they will not allow any IC engines. UK has said that by 2030, they will not allow pure IC engines to operate. And maybe to 2035, they will not allow hybrids to operate, right? Even IC engine hybrids to operate. So in such a scenario, even from a CO2 standpoint, like, for example, if we look at EU, the CO2 regulation in 2020 was like 95 grams of CO2 per kilometer. In 2030, they are telling 59. So that's like a 39% decrease. So at a sustained level, I mean, I don't see IC engines being continued for more than, let us say, 10, 15 years. I mean, at the most, you're looking at 2040 perhaps, because by that time, more than 30, 40%, I mean, even by conservative estimates, if EU has to meet what they're telling, 59 grams of CO2 per kilometer, they will need to electrify at least 35 to 40% of the vehicles. Now, if the whole world is doing that much of electrification, I'd find, I mean, very hard to digest that India can be totally oblivious to that development and looking at something new, because technologically we have always been drawing inspiration from these countries. Third thing is the commitment. Like, for example, ESG and Government of India has given a commitment by 2070 we'll be doing this. There are other countries which are telling that by 2050 we'll be at zero. So what I see, I mean, based on my experience, is their hydrogen economy is something that is possibly a good thing to look at this point of time, because apart from say using nuclear energy or one of the difficult things, like earlier Ajay was mentioning, that we don't have sufficient electricity. But there are studies to the contrary as well. For example, a few years ago, Lawrence National Lab along with Niti Aayog had done a study as to how much electricity as a percentage does India really require to run all the vehicles. And they came out with a value of 6.6%. That's the peak value. On an average, it was only 3% of the energy consumption. But this looks very ridiculous at this point of time. I mean, even for when I was at Mahindra, it was very hard to digest. Hey, why is it such a small number? But when you look at it, most of the electricity consumption is actually coming from industries, and what is being projected for air conditioners is actually a huge energy consumption. So if Government of India is looking at addressing the industry needs and also for the use of electricity coming out of ACs, this portion that at this point of time will be needed for electricity is actually very less. So my take here would be this is a very good opportunity for industry as such to collaborate. Very good opportunity for industry as such to look at things like transmission loss, like electricity. 20% to 30% is a transmission loss, right? So that's conveniently neglected, and look long-term in terms of a hydrogen.
Understood. Sure. Thank you, Mr. Sarunan, I think, for sharing that very detailed analysis on how the conventional powertrains are trying to be stretched by most OEMs to meet the future norms, but at the same time, given how stringent they're getting, it's inevitable that we will have to move to things like EVs. And taking on that point, I would like to move across to you, Mr. Saurabh Saxena. So, if say we have a bullish estimate for EVs coming in, and including for the world as well as for India, that brings to light, certain risks across the EV chain, whether it's supply side risks like cost fluctuations, import dependency, high lead times, or for the raw materials, or even the intermediate materials that go into batteries, or even, the delivery risks of product failures, as we've seen in the recent past also. Thus, for this successful transition to happen, and having a robust sort of EV ecosystem in place, do you think all the stakeholders need to probably collaborate on things like raw material sourcing, developing the charging infra, and customizing the products very importantly to the Indian conditions? And therein do you see that, probably it would be also a good idea, especially from a heavy trucking perspective, to at the same time also keep looking at hydrogen or FCEV as a parallel movement in this regard?
Thank you for your question, Asim. Yes, it is true that we cannot electrify the whole world with the available raw materials that we have. Yeah. So definitely there has to be a parallel solution which has to coexist. And as my co-panelist hinted, hydrogen is one such solution, which will give a good balance to the carbon footprint and also solves the problem of the environment. So yes, hydrogen is one such thing which can be a big boon for India, because we will not have to be dependent on all the electronic raw materials that we need for the complete e-mobilization of the transport industry, all the charging infrastructure. Clean and sustainable energy is a big question, because we need to see the well-to-wheel approach when we decide on our future propulsion roadmap. That how we produce the raw materials, how we get this energy, how this gets transmitted. The tank-to-wheel approach will not serve the bigger purpose. The big picture will not be addressed if we are focusing only to tank-to-wheel solutions. No? OEMs can, yes, definitely, as Daimler Trucks, we have the technology of e-trucks, hydrogen mobility solutions, fuel cells. So we as Daimler are ready with these technologies, but we need to see the whole ecosystem of a given region. Are we ready as a whole ecosystem to provide all the inputs, all the raw materials, the energy to use this technology? So these are the challenges which we have to tackle as a nation, and therefore it needs a whole collaborative approach, right from OEMs to the component manufacturers to all the solution providers, that we see the whole solution from well to wheel and not tank to wheel as a big picture. And whatever solution we develop has to be sustainable. We should be able to pass on and continue to operate that ecosystem. So this whole ecosystem has to develop, and we as Daimler are ready, and we also want to play our part to address this problem as a nation, as one nation. So we did the same for BS6. As you know, from BS4 to BS6 was a pretty quick jump for India. We skipped the BS5. And from BS4 to BS6 in just 3 years was a big challenge. And we as a nation, we took this challenge, right from OEMs to the testing facilities and the component manufacturers, we transformed ourselves. So this development cycle was very quick and very short, very intensive for sure. And we as Daimler, we did this with the global collaborations that we have with our other Daimler development regions in Japan, Germany, Brazil, and US. And we said we need to have this solution for the Indian market. And that's how we decided that BS6 with this SCR-based solution was our solution for the Indian market, which we feel was more efficient and suitable for the Indian market. So we developed this product in a very quick time, to less than 3 years. And this we did it with roughly 10% better fuel economy than the BS4 vehicles. So this was a pretty big achievement, I would say, not only for Daimler India, but the whole automotive industry here to make this big jump. And we need a similar approach now in deciding the hydrogen transition to hydrogen mobility or to the EV mobility. So yes, this collaborative approach is the need of the hour, and yeah, we will do our part as OEM in making India, a greener place, a sustainable green environment.
Sure, thanks, for sharing. Of course, collaboration being the mantra, and we see a lot of that also happening in the EV space. Most recently, the Mahindra Volkswagen tie-up also in this space, and also for sharing that case study on BS6 and how it was done. With that, I take, still staying on with what Mr. Saravanan said of, that OEM is trying to use the powertrain to the maximum. And then once it gets more stringent, they'll probably move over to something else. But I think for that, from a testing agency standpoint, Ms. Pamela, I think you need to keep the infrastructure ready, till the OEM is testing. At the same time, we also heard from Mr. Saurabh Saxena about the shift towards hydrogen FCV. So you need to get the infrastructure in place for that also. And you yourself highlighted also the skill sets for all of this. But say from a utilization standpoint of these setups or the people who are working on these, doesn't it complicate the problem even more for you? Because you have to be ready for whatever is coming your way in terms of testing, and there could be a switchover, but you could be saddled with capacity, with skill sets for something that suddenly falls out of favor with most OEMs. So how are you trying to address this kind of a complication?
Ashim, as I said, since we are part of an ecosystem which goes into deliberations and policy formulation, so we are aware of what is happening and what is going to come up. So we plan our investment in terms of facility creating, keeping in view what is finalizing. So that gives us, as I said, 3 to 4 years time and training people. In terms of utilization, if I may say, I can give you an example. When BS6 came, when BS4 was there, ICAT had 2 emission test cells, chassis dynamometers, and I think 4 engine dynamometers. But knowing the industry requirement, which will entail once the BS6 will be coming, we created an infrastructure. We upgraded our emission facility to 6 emission test cells for chassis dynamometers and 20 engine test cells for engine testing. And believe me, 2018-19 was our peak performance time because of BS6. The utilization of those facilities was so high. We used to operate engine test beds for 20 hours, 22 hours continuously. And there used to be a fight between, every OEM asking, we need the test facility, we need a test facility. So we tried to, gear up ourselves in terms of requirement with the industry, because such infrastructure investment for any manufacturer will not be an economically lucrative decision. So we create a facility which is being used by many OEMs, and they can, they use it for development purposes as well as for certification purposes. Of course, after the BS6 came, the utilization went down suddenly, and then COVID happened. But then, we whatever we invested, we actually recovered that in 1.5 years time frame, 2 years time frame. So that was the kind of utilization we had. So that's the advantage that, as an organization, we have this common facility which can be used by different OEMs who do not want to invest, and, investment in such facility by one particular OEM doesn't become a economically viable solution. And hence we were able to get our ROIs on those facilities. Similar is the case with the RDE also. As I said, we invested well in advance. We had 5 RDE facilities with us. And once the RDE data collection happened, RDE type approval happened, this enabled us to do certification faster. So there was less time required for OEM to certify those vehicles and put their vehicles on market. Now you're talking about hydrogen economy. So hydrogen economy is a totally different ballgame, okay? Going from IC-based engine where the liquid-based fossil fuels engines to gaseous fuel was easy to manage. In my same test facility, I can use a liquid fuel, I can use a gaseous fuel. But once we move to hydrogen, it's a different scenario altogether. Because hydrogen has certain inherent properties and issues which does not enable it to be used as easily as other fuels, with other gaseous fuels or other liquid fuels. And because of its inherent safety issues, because of its compatibility with materials, which entails a very thorough investigation and planning for creating an infrastructure. Similarly is the case with fuel cell also. Creating a fuel cell facility has also, because it will be handling hydrogen. So we need to have a very different infrastructure for handling fuel cell and hydrogen ICE. So currently we are not ready with ICE, hydrogen ICE facility, or for that matter, fuel cell testing, because of these 2 reasons. The other important reason for not making any investment in these technologies at this moment is because we do not find that in next 4 to 5 years time, there is going to be a market for these technologies in the country. Hydrogen has been talked about to be the fuel for future and the ultimate energy source for the world. I have been seeing the development of hydrogen, economy since 2004-5. So there was a freedom fuel, freedom car initiative in US. In India also, we had a big initiative. We created a roadmap for hydrogen fuel cell. We need to understand that, hydrogen transportation is not easy. We need to create an infrastructure for transporting hydrogen from one point to another point. Then dispensing hydrogen. Hydrogen ICE will not have a purity of hydrogen issue, but once we go into fuel cell based technology, then hydrogen purity is very, very important parameter when we want to run vehicles with fuel cell vehicles. So whether we can have a piped infrastructure for transportation of hydrogen, what kind of purity can be, ensured through that, and what are the feedstocks for hydrogen generation? That's a very important factor, whether it will be from industries or from refineries, what kind of, or from biomass. So what kind of impurities will it have? How the fuel cell will behave in it? So these are the questions which globally have not been, addressed to a greater extent. So it's important that we work in these technologies, but it's also important to understand the challenges for adapting this new fuel. We need to have a full integrated hydrogen transportation mechanism, pipelines. We need to have a proper dispensation of hydrogen, which is as widespread as our fossil fuel. Then we need to also have material compatibility issues to be addressed in vehicles, in test facilities like ours, when we handle it. Safety is an issue. Transportation of compressed hydrogen on a vehicle is another important issue, because hydrogen cylinders, hydrogen cannot be transported in the conventional cylinders. You need composite cylinders, which are high pressure cylinders. Hydrogen typically is carried at 600 to 700 bar pressures, which are very, very high pressure. So those tools and mechanisms need to be in place if we want to embark on the hydrogen economy. Creating a test facility, the moment we find that there is a market and there is a utilization from the industry which is going to require, we'll need to create stepwise infrastructure, upgrade our facilities, whether we can create in our existing location or we need to have a different location, because whatever I've seen, wherever I've seen, hydrogen testing is in a very different location. You have to have a very specific safety features installed in that infrastructure. So that will create a whole new infrastructure that will be created as a new facility itself. It cannot be handled in the existing facility. At this moment, we are talking and working on the feasibilities of these test facilities, what kind of investments will be required, and how we can do it. So we are still not there yet. But as far as the batteries, EVs is concerned, we are there. We can do all kind of battery testing, all testing. We can do full EVs, we can do hybrids, we can handle all fossil fuel and gaseous fuel vehicles. We have been involved, ICAT has been involved in a very important initiative by Delhi government and IOCL, wherein the hydrogen CNG fleet was run on Delhi roads, and ICAT was involved in assessing the benefit that is reared by this hydrogen CNG fuel mixed vehicle on the Delhi transport vehicles. So we saw that certain fuel efficiency improvements and certain NOx reductions in there, but CO2 reduction, NOx, not so much of NOx. And those studies have already been submitted to government. And hydrogen CNG mix we have been handling in our facility for a long time, I think way back from 2008-9 times. So there were certain experiments done by Mahindra where the hydrogen was blended with CNG. There were certain experiments done by Tata Motors. So blended hydrogen with CNG, yes, we can do it now also. And pure hydrogen, we are still to plan for that.
Understood, understood. So I think clearly, as you said, for the regular technologies, the utilization came in because you inherently make people collaborate and use those facilities since you set them up, as a one-stop facility for all OEMs to use. But hydrogen, you clearly pointed out the complication. It's H2IS, it's FCEV, but HCNG you already have done. So thank you for sharing that perspective. Moving on to you, Mr. Sanjeev Saxena, and you touched upon, the importance of friction reduction, and which becomes even more important when we look at EVs because it directly impacts the range, hence, the battery size that you're putting in and things like that. So now we see that also bearings in EVs is probably slightly more complex because the rotational speeds are probably higher, leading to higher bearing temperatures. Also, there is high and fast voltage switching of the electric motor inverter. Given these challenges, how are bearing manufacturers planning to gear up for the EV market in terms of design, robust and real-life testing to ensure that there is a reliability for the consumer and the OEM, especially also because many of the things that these bearings may be going into may or may not have been localized in India right now. So your perspective, and then, later on, I'll also request you, Dr. Savan, to share your perspective on the same question as well from the NRP side. Yes, Mr.
Okay, let me just begin by saying that Schaeffler, though people think that our primary business is bearing, but when it comes to automotive, and I head the automotive division for Schaeffler India, about less than 30% of my revenue, the top line, comes from bearings. Most of it comes from powertrain solutions and the clutches and so on and so forth, and also a lot of engine components. Now, when we talk about friction reduction, we do not start at the bearing side. We start right from the engine, and from there throughout the transmission, and then finally to its bearing. So when I was alluding earlier to the weight reduction parts in those things, I was actually talking about the transmission side within the transmission kind of solutions that we are actually working on. And we've been able to reduce a significant amount of weight in that area. Now, coming to the overall friction reduction and what are the challenges? The challenges are huge. When we talk, and let's understand where the bearings are going to be. And today, the bearings are starting from engine, powertrain, right up to the wheel, in steering system. In every system that moves, there will be a bearing. Going forward, when we go to electrification, these bearings will, there will be a very different ball game as far as, and I'm talking specifically electrification here. The bearings will start from the motor. And a motor, depending upon the kind of motor it is, it may have numerous number of bearings, up to 7, 9, and that kind of bearings could be there. And each bearing performance will be quite different from what we have in another scenario, depending on motor rating and so on and so forth. And yes, you talked about high speed. Yes, definitely high speed. Another area is high temperature, and that's quite a difficult area to handle, because then you're getting into specialized metallurgy, specialized processes, and very specialized, in some cases, thermal management solutions. And one of the biggest area that will happen with electrification is managing the temperature, high temperature. So that's where the thermal management part comes in. And by the way, we at Schaeffler have worked a lot on thermal management aspect also. That's thereby making powertrains more efficient. Coming to the next part, I think when we talk about whatever kind of transmission we use an EXL, we use whatever we use, there will be a transmission, and there will be transmission bearings. And these transmission bearings will be required to be very specialized, very different kind of bearings, starting all type of bearings, TRBs, NRBs, and so on and so forth, apart from the traditional bearings which will go onto the wheels. So And also, we are also looking at what it will, once again, across the segment, what it means to different segments. So at Schaeffler, we have solutions for high-speed, high-temperature bearing in almost each and every segment. And those are, friction reduction is one of the things there, but the key aspect is maintaining the performance and making sure that at that high temperature, at that speed, we can't afford any failure. So reliability is one of the key things. Now, just going a little further, if we talk about the overall powertrain, when we look at the electrified powertrain, of course, the moving parts, it becomes much simpler. Bearings and the bearing will play an extremely important role, because they, whatever moving parts are there, they will be harboring. I mean, they will be actually supporting that. Coming to the drive side, when we talk about the steering system, etc., I think things will remain. A lot of friction reduction, which today in current IC engine takes place on the FEAD side. A lot of that will probably go away. Oh, yes, there will be certain things for air conditioning and so on and so forth, but a lot of those things like fans, etc., probably, we don't know. A lot of those things will go away too. Like auxiliary, a lot of auxiliary things will go away. So that's where the friction actually, the reduction automatically will take place, and there you probably do not need the advanced solution. So in a nutshell, if I say that, I'm talking specifically EVs, as far as the bearings and the moving parts are concerned, we have to make sure that number one, they are light. Number two, they are able to work in the extreme conditions, very high temperature, very high speed, and then providing reliability at that kind of working condition. As far as wheels, etc., are concerned, I think that is something which can still be handled, and that will be much. There is certain things involved there also, but not so much as the internal moving parts of the whole powertrain, electric powertrain.
Sure. Thank you, Mr. Saxena, for that. Dr. Saravanan, yeah, your perspective also on the same.
The first thing that affects when an EV comes in, I mean, from a bearing standpoint, is the number of bearings, because most of the bearings actually go in powertrain, right? So roughly speaking, if you take like a sedan, like a Swift, or maybe like a hatchback, a regular hatchback, they have around 55 to 60 bearings, roughly speaking. And when you go into an EV, the number of bearings goes to half. So it's roughly, because the engine is gone, the transmission is no longer a regular 6-speed MT or a 7-speed MT and maybe let's say a 10-speed AT. So it's more like a gear reducer. So the number of bearings is less. So that said, from a bearing manufacturer's standpoint, we have to offer more value to the OEM. And for our own good, I mean, otherwise there will be no revenue. I mean, you will have a straightforward fall in revenue, let us say. The OEMs, because of CAFE, the stage 1 in India, for example, CAFE stage 1 to stage 2, there is a reduction of around 17%, roughly speaking, that's being required. And OEMs are also very hard pressed. So they are pushing us for friction reduction. So we recently had a request from one of the OEMs, a two-wheeler OEM, saying that we want you to reduce bearing friction by 30%. And of course, this will be a very small contribution when it comes to the overall fuel economy, but I mean, they're trying to squeeze each and every one. So we were able to make a prototype by looking at the design of the interior parts, let us say the cage or the retainer, by reducing weight, by looking at designs, by looking at newer lubricants. So that's number one activity that we have been doing. The second thing that differentiates between a regular engine application, in a regular engine application, pretty much the torque is very low at idle RPM. And you have the torque increases with the increase in speed and then goes down. But in an EV motor, potentially a fellow can pump in, because an EV, even at 0 RPM, can give high torque. So potentially, when the lubrication is very less, because you're relying on some kind of hydrodynamic lubrication, and that depends on speed of rotation. So if the bearing is at standstill and somebody puts in a good amount of torque, then you actually end up hurting the bearings. So the other aspect that we need to work at, especially with the EVs as lower speeds, how do you ensure that things don't collapse? Right. I mean, you still have some kind of a lubrication and you don't have a metal-to-metal interaction. The third aspect that we look at is from a noise reduction point of view. Now, in a regular IC engine vehicle, the IC engine obviously is the biggest source of noise. And transmission also is some source of noise. Now, coming to EVs, there are only two other sources of noises that is left. One is the wind noise, which in practically most of the new cars hardly exists. I mean, it's very low level. And tire noise, which we cannot do away with, right? So under such a circumstance, even small noises become very perceptible. Just to give you an example, like in a regular car, I mean, if you turn on the blower, at 1 and 2, it's fairly imperceptible. But you turn to 3 and 4, the noise is so perceptible that it doesn't allow you to speak. Now, when it comes to EVs, even though the same bearings exist, but the expectation that the OEM has is much, much lesser noise. Because there is a quiet environment to start with. So that's something, that's an additional thing that they insist. The fourth thing from an EV standpoint is accidental electrical discharge. Now, in an EV, very high voltage, if an accidental electrical discharge passes through the bearings, you will have arcing, and you will essentially have welding of the rolling elements, or it could be a ball or it could be a roller onto the races. So to avoid that, the kind of things that you look at is you either look at coatings, like a ceramic coating for insulation, or ceramic balls, even an entire ceramic bearing in some cases, or some people are looking at shunting the electricity, like a shunt resistance across the races. So these are the kind of things that, the challenges that EV poses onto a component manufacturer, in our case, like a bearing manufacturer.
Got it. Thank you very much to you, and also to Mr. Saxena for sharing, that very wide perspective on bearings and the complications that are coming. And certainly, Dr. Saravanan, the noise part that you said, I think it's quite perceptible. Even every time we take a blue smart cab, which is an EV, we can suddenly see we're in a much quieter environment out there. Just before we move to the audience questions, I have one final question for you, Mr. Saurav Saxena. I would request your perspective on that also after that, Ms. Pamela. We see that, there are a lot of complications around so many powertrains and so many options to look at. Don't you think in the light of this, if, say, we had a long-term regulatory roadmap in place, both for the emissions as well as for safety, it would make life easier for everyone? The OEM, the component manufacturer, for the test agency. So broadly when what is going to come, so you can have enough time for developing the technology at hand for it. Also from, say, if some infrastructure has to be developed so that for that technology to be optimized in the best manner, even the infrastructure creators can also work as per this roadmap and try to create whatever is necessary. So why is it that something like this has not been done? And do you also agree that, something like this is the need of the hour now for India in order to be able to progress in a sustainable manner towards the future? So Mr. Saxena, I'll start with you.
Yeah, absolutely, Ashim. I think roadmap like this, if it is available, that will make most of our lives easy. The OEMs, the testing agencies, the component manufacturers, so that we can plan ourselves, ahead of the future. But we also need to understand the perspective from, the policymaker side, because it is not easy to come with one-stop solution, and define that, yes, we will switch to this technology by this year. So I think all of us are evaluating this whole scenario in parallel, which should be, we know the final picture, we know where we have to be eventually. We have to be carbon neutral as a nation. So that's the big picture, the aim we all are moving towards. But is this possible in one step, or we need to take smaller steps and then eventually lead there, is the question. And if we have to take smaller steps, phase-wise transformation, what should be those phases? That has to be mutually decided, because it is not only the technology. Technology can be made available. We as Daimler Trucks, we have all the technologies which are needed, but can be implemented immediately in any given market or region? Maybe not. So we need to see technology, a balance of technology, the infrastructure, and all the ecosystem, as we discussed earlier, that when and how we can invest how much in all preparing all these ecosystems, and how we reach that eventually. So this is not an easy thing to ask. Yeah. So it definitely, that's why it is taking some time, and we say we are in a messy middle, this phase. There are so many options available, which way to go, and all are obviously all these options are better than the current situation. Be it moving a better emission levels from the current BS6 norms, bringing up better RDE norms, fuel efficiency norms, safety norms. Definitely, we are on the right path, but making a big leap is not possible. So we need to take smaller leaps, but definitely all what we are doing together as an automotive society is in the right direction. And yes, ideal situation, if this roadmap exists, we all will be happy, but I don't think so. It will be so easy to define such a roadmap very clearly.
Sure, understood. Thank you. Ms. Favila, your perspective also on that, final words of this before we move to the audience questions.
Ashim, yeah, if you remember, India had an auto fuel policy,
right,
which was framed way back in 2002, 2003. So it defined clear-cut roadmap up to BS4 level. So that was the scenario and policy environment at that point of time. So the environment was not so stringent on various targets, be it for CO2 reduction or be it fuel independency. So that's why there are subsequently the clear-cut roadmap has not been evolved further beyond BS4. Secondly, the dynamism of policy, both national level and global level, is ever evolving. And hence, as a policy makers, they have to align the policy decisions based on the commitment that as a nation we take within the country, and also in the international global forum, the commitment that we have made. And that's why there is a lot of dynamism. And I think we have been talking about electrification for so many years, but none of us had imagined that electrification will happen like this. None of us had imagined that there will be connected mobility in India like this. The new generation, the Gen X that was being talked about, no longer wants a car ownership. They find it more as a burden. They say that from point A to point B, if I have to go today, I'll go in a Swift, tomorrow I can hire Toyota, next I can hire a Mercedes-Benz vehicle. So why do I need to have a car for which I have to have a parking, I have to have insurance, then I have to have a lot of other hassles to manage. So he has to drive. So nobody thought that, the consumerism will change so much. The consumer will change so much that from self-owned vehicle to going to not at all self-owned vehicle. So these are various dynamic situations which have happened and which are happening, which are constantly evolving. And hence, probably that's the reason why the clear-cut path cannot be defined, because we also don't know that whether India can embark on full electric transportation, while the dependency will move from fossil fuel to lithium ion. Can we afford that as a country, or should we develop solutions which are for our sustainability dependent on the local resources we have? So these, and we cannot have a abrupt shift of technologies also, because the whole economy will get into a mess. You would have seen that when the COVID happened and there was sudden embargo upon importing of certain companies from certain geographies, the whole industry, not only auto industry, the whole economy was impacted, because suddenly there was a break on supply chain, raw material availability, and then government changed the policy. So we will be thinking as per our own, perspective, but there is a larger global perspective at a national level and a global level, where the policymakers have to make certain decisions which are in the interest of the country and in the industry, interest of the economy also, because India is at a point where we are growing economy, and we are growing at a faster economy, as was shown by the gentleman from Frost and Sullivan, that ours was one of the biggest growing economy among the roadmap that was shown. So as a policymaker, we would not like, the government would not like to put any brakes in this growth story. And the initiatives of Atmanirbhar Bharat, the self-localization, which the government is trying to, focus, is to develop self-reliance. The classic scenario of semiconductor shortage, not only in India but globally, has made all countries think that from globalization, which was the mantra pre-COVID time, it is now nationalization and localization. Have local product, locally develop, and have local dependence. So these dynamics keep changing such policy decisions. I think, as was rightly said by Saurav, it's important to have small changes, small steps, have success in it, rather than have something for which we are not very sure about how the things will pan out.
Sure. Just to clarify, when I said roadmap, I didn't mean that saying that EVs come in this year or FCEVs come in this year, but more like the targets.
Yeah, CO2 targets also are evolving.
Yeah.
So if you go to CO2 based target also, then I will say that hybrid technology is the easiest one to go to give you immediate benefit,
Right.
But we are seeing that hybrids are not being popularized in India for whatever the reason it is. There's a focus from government on EVs because they want to propose, and they are great proponent of full EV vehicles in India. So as you said, CO2 based target would be the ideal situation, but we really don't know as a country how we'll go about it, what kind of fuel mixes we'll have. Ethanol was a classic example, Ethanol started way back in 2007-8, and it was started in a big way. But then the blending stopped because ethanol became expensive rather than the fuel itself, crude itself. And the fuel companies stopped blending ethanol in the gasoline. So the dynamics of pricing, the dynamics of availability is all what will bring out what is going to be the right mix of fuels for the country.
Understood. Sure. Thank you. Thank you for that perspective. I think with that, we'll just move on to a few audience questions. I think the first one here is for Mr. Saurabh Saxena and asked by Ketan Patni. What is the scope of differential gearbox in EVs? Will the inline motor supplying power directly to the wheels rule out the differential gearbox?
Yes, thank you for this question. Yes, the mechanical differential will have I would say no or limited chances in the electric vehicles, but we still need to supply differential power, or that I would say torque, to the wheel ends, and that will be done by e-axle. I mean, we do the same job, but not mechanically through an e-axle. So you would not see the typical mechanical differentials in the electric vehicles. Yeah.
All right, thank you. The next one is for Dr. Saravanan. Dr. Saravanan, you explained the OEMs are converting existing vehicles into EVs. How are these proposals attractive from the end consumer perspective? Probably they will not see any outside, a visual difference in the vehicles. But when it comes to startups, they are developing completely new vehicles, new design, which could be more attractive to Gen Y. Do you see this also happening to a large extent? I think it's more like talking about, say if you retrofit an EV powertrain into an ICE vehicle as against developing a vehicle grounds up for EV.
I agree. Maybe from a look standpoint, that whatever the startups are proposing is something new. And as Indians, we want to be different. So we generally look at a new design. At one point of time, in Maruti, for instance, we had an internal survey wherein one of the family members actually said, I'm not considering Maruti vehicle because you don't have that Figo green. The Figo and the Spark used to have that green, which we didn't have. So obviously, customer looks at various things. But if we look at what an OEM does, you take Tata Nexon, for example, right? It's a good EV. It's coming maybe based on a diesel platform, but you don't have too many problems. But on the other hand, the two-wheeler startups, you've seen quite a few instances of fire. So look definitely is important, but probably not more important than safety. And the OEMs are also realizing this. It's not that they're not realizing. For example, Mahindra has come out with the concept of a PON EV. They're also collaborating. Mahindra is collaborating with Volkswagen. Suzuki is collaborating with Toyota. Because the amount of money required to make a chassis from scratch is just too huge. Like I was mentioning, roughly around 1,000 crores. So OEMs are realizing this. They're collaborating. So hopefully we'll have better designs from them in near future.
Sure. Thank you. The next one is for Ms. Bebela Tiku. Regarding the recent pilot project iCAD and Toyota has initiated on the Mirai hydrogen-powered vehicle, by when do you think the project is expected to get completed, and when can we expect the key learnings of this project to be out?
The project is basically for 2 years time frame. So starting from Jan 2022 to Jan 24. So it's only after that only the key results will be known to be.
Right. Okay. Thank you. I think the next one is, they haven't mentioned whom the question is to, so maybe I'll direct that to you, Mr. Sanjeev Saxena. How can we say that electrification will be possible? Because nowadays we are facing a problem in charging the batteries, that it takes a very long time to recharge, and traveling long distances is also not possible. I think they're more hinting towards probably lack of a widespread charging network. I think you're on mute. If you could unmute, please.
That's a very interesting question. And whenever somebody asks me this question, I go back to my days in NCR in 1997, when the unleaded fuel had come in. And if we had to go anywhere outside, we had leaded cars. And so we had to really plan how to go about that. It's been about 25 years now. And you go to any place, unleaded fuel is available. And it was, no, the comparison is not apple to apple. But the thing is how these things actually evolve. Charging infrastructure and the affiliated paraphernalia, I think that it's just a matter of time. There are enough entrepreneurs in our country, they know how to spot a good deal, and they're already working on it. And as we speak, there are, when we look at, there's a space next to my office in Pune. It was a junkyard about 3 months back. Today we have a parking space for about 70 buses, 35 chargers in place in less than 2 to 3 months. And all this has been done so quickly. So these things are actually mushrooming overnight. And for me, I don't see that as a huge challenge. Yes, 3 months, of course it is a challenge. 6 months, yes, it is a challenge. Take a horizon of 5 years. No, it is that I think is least of the challenges that we should talk about. That of course the range, where it will be available, all that. Will it be available in every village? No, but will it be available in tier 1, tier 2 cities, and where most of the mobility will take electric mobility will take place? The answer is most probably yes.
All right. Sure. Thank you for that answer. There's one final question, again, not directed to anyone, so anyone can attempt it. They're saying one sustainable route may be vehicle retrofitting, but powertrain modification may be an issue. I think Mr. Mohan Kaliyappan has asked this. I think he means EV retrofit. He's saying powertrain modification may be an issue. Any cost-benefit analysis that has been done for a popular three-wheeler or four-wheeler EV model on retrofitment of EV powertrain? I don't know if any of you are aware of any such experiment, if it has been done.
If I may answer that,
sure,
I'm aware of a company which is working on this. In fact, it's a pretty big organization in automotive field in India, which is actually making it retrofitting as a business stream, and they are already talking about significant revenues coming out of there. I don't want to name them, but this is something which I have learned. Maybe they've been working on it for over a year. So yes. And specifically that the last mile connectivity, when we talk about the three-wheelers and the light commercial kind of vehicles, yes, there is a possibility, and there are people who are investing in that area.
Right.
I also know a couple of startups are working in this area, so they are finding it as a very interesting business proposition for converting IC vehicles into electric vehicles. And there was some daily tender also in this regard. So there are people who are working
Okay.
Just adding to this, yes, this will also emerge as a business model, like right now we have for the gas engine conversions or the bike. But in case of EV vehicles, we need to be very careful because we deal with high voltage, components. So the safety of the passengers and this whole product is very critical here in this case. So yes, so this has to be managed.
Right. Sure. I think with that, we've had a wealth of knowledge, that's come across through this panel discussion. I thoroughly enjoyed myself talking to all of you, and I'm sure the audience have gained a lot from this. And with that, we thank all of you for being on this panel discussion, and also the audience for all the questions that they asked. Thank you very much. Back to you, Mukul.
Thank you, Ashwin, and thank you all the panel members. It was a pleasure to be part of this panel.
Thank you.
Thank you.